Hello and welcome back to the Building HVAC Science Podcast. It's our goal here to create better, more knowledgeable HVAC and building performance technicians by helping the two professions better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. In this episode of the podcast, Eric and I welcome special guests Ed Smith and Eric Fitz from Amplys Energy. Now, we begin by sharing our experiences, our joint experiences, because all four of us were there at the recent HVACR school symposium in Claremont, Florida. And we highlighted and had a really good time talking about the significance of personal connections and shared knowledge in the industry. Ed then shares with us his transition from operating businesses to co-founding Amplys with a desire to make significant impact, particularly in sustainable agriculture and decarbonizing chemical manufacturing. Some really interesting career paths. Eric Fitz this time, shared his background in mechanical engineering and his journey through the energy sector, which led him to co-found Amplys with Ed Smith. Eric expressed his passion for energy and building science, emphasizing the importance of advancing residential building systems to improve the overall energy system. We then shifted our discussion to talk about the application of Amplys software, which aids HVAC and heat pump installers by simplifying and speeding up the sizing and designing of systems for retrofitting in homes. The episode concludes with our insights into the electrification of the HVAC industry, something I talk a lot about, the challenges and opportunities it presents, and the role of modern technology in supporting the transition. And we all stress the importance of collaboration, innovation, and education in driving the industry forward, with a particular focus on improving HVAC design and installation practices through the use of advanced tools and software, especially those that adhere to ACCA Manuals J and D. Share some links to Ed's LinkedIn profile, as well as Eric's LinkedIn profile, as well as a site link to Amplys Energy, amply.energy. Okay, let's get into the conversation with Eric and Ed, talking about heat pumps, homes, and high-tech HVAC evolution.
Hey everyone, welcome back to the Building HVAC Science Podcast. I'm your co-host Eric Kaiser, and virtually next to me again, Bill Spohn. And today we have two special guests from Amplys Energy, Mr. Ed Smith and Mr. Eric Fitz. And just to keep things confusing, now we have two Erics in the room, so I'm going to go by Elk today. Take it away, Bill.
Thanks, Elk, and welcome Ed and Eric to the podcast. So let's start off. All four of us just returned from Florida from the 5th annual HVACR school symposium. We got to meet in person there, and you were there probably for a good reason. We'll get to the reason after you give introductions. And first, just in order on the screen here, I'll ask Ed and then Eric to give us a nutshell background.
Thanks for having us. Super excited to be here. So, Ed Smith, Eric and I have been friends since freshman year of college. So we've known each other for 25 years. My passion area is operating businesses. After college, I got my MBA. I joined a big consulting firm. I was there for longer than I should have been, but it was great education. I learned from dozens of businesses and leaders and managers and different industries. Great education. But I wanted to operate a business. So I left and joined Wayfair, the online e-commerce home furnishings company. They wanted me to come over and run the US furniture business, which was a giant business for them. And I jumped at the opportunity. While I was there, after running US furniture, they asked me to run all of Canada, which was smaller, but 10 times more interesting and complicated. And I grew Canada for Wayfair from 400 million to just shy of $1 billion in a little over a year, which was a heck of a ride. And a great opportunity to learn how to run a tech business and a hyperscaling tech business. Great time there, but I was selling furniture on the internet in Canada, which I cannot say is what I would have imagined myself doing when I grew up. So after a great ride at Wayfair, I got into a couple different startups with inspiring missions. One was looking to make agriculture more sustainable in the US, and the other one was looking to decarbonize chemical manufacturing. And at both of those two startups, what I did was I started business units from scratch. So I was the first employee, ran the businesses, hired the teams, did all that. And those were great rides, but they felt like entrepreneurship with training wheels. So around that time at the second one of those, my good friend Eric Fitz was kicking around this idea for Amplys. So I left to co-found Eric with Amplys. And that's what I've been doing for the last 2 years. That's me in a nutshell.
I got a follow-up question. Seems to be a lot of interest from people like yourselves in this space. Do you have any clues as to what's driving that?
We do. I can tell you from my perspective, it hits close to home. So I electrified my own home, like decarbonized my own home. It was the first and one of the most actionable things that I could do. Sorry, Bill, let me actually clarify your question. Do you mean climate or building electrification?
People from tech, we'll just say that. People who have worked in scaling businesses, new ideas from the ground up. Why do you think that's become of interest? Is it some crossover between demand, need, opportunity, technology solutions coming together?
I think it's all of the above. Silicon Valley has thought of itself as changing the world for the better for a long time. And I think that hasn't always been true. There are things that really feel like they're moving the world forward. And I would say that electrification, decarbonization are one of them that feel like obviously like a once in a generation opportunity if we do it right. And it feels like where the playbook of tech and scale and impact is incredibly relevant. Maybe that's a little bit dangerous because when you have a hammer, all the world looks like a nail, but I think that's part of it. This problem looks like a nail for that playbook, and the mission behind it is incredibly inspiring.
I'll switch over to Eric now and have him give his background.
I'm Eric Fitz. I am a trained mechanical engineer. I'm a big-time energy and building science nerd, electrical grid nerd. My first job out of school was at General Electric. I used to design gas turbine compressors. I worked on wind turbine blade design and geothermal power plant control systems. When I was working within the wind business, I saw how policy done well could really create a market. And when it was done poorly, it would kill the market. I'm definitely a technologist and engineer, but I realized I needed to learn more about this intersection of policy, business, and technology. So I joined a consulting firm. I got to work on projects advising utilities, private companies, governments on a whole range of topics. A couple that I realized I was really drawn to projects that involved a lot of modeling. So I built models for the National Renewable Energy Laboratory. And I had the opportunity to work on a project for the Department of Energy, specifically around standards for commercial refrigerators. And that was almost a 2-year project on its own. And it was really my first deep exposure to building science, to load calculations, to manual J, to energy modeling. And it was super fun. I was living in Silicon Valley at the time, and I've been writing code since I was a little kid. So I got bit by the startup bug. And I joined a couple of startups that were actually outside of the energy space. And honestly, they were total disasters. But I learned that I love early stage software businesses. I learned how to build mobile software products. And I learned how not to build a business, which was really valuable. But I missed my passion area, which is really energy, electricity, building science. And I had this idea for a product when I was working as a consultant that could aggregate all energy policy, state and federal, across the country into one place. I found this amazing nonprofit who wanted to make that a reality. So we built it. It was an incredible experience. I got to collaborate with Microsoft engineers to build the first AI that could predict the outcome of legislation. I got to work with amazing, passionate people at this organization, and we created a product that is still used by some of the biggest names in energy. I was there for 9 years. And during that time, I was constantly doing home renovations. My wife would say they were experiments, but don't worry, she knew what she was getting into on our honeymoon. My fun reading, my light reading was a 400-page book on residential electrical codes and home wiring. So I love home renovation. I was doing all of it in my own house. I've helped friends and family work through the same challenges. So that's why I co-founded Amplys. I love energy. I love building science. And residential buildings are really the atomic unit, I think, of the energy system. You've got these energy inputs and outputs, this dynamic system that's impacted by the environment and its occupants, but it's our home. It's where we raise our families. It's where we create memories. And I just think it's the most important place to have an impact. And if we can do homes right, we can make the whole energy system right for the next generation. So close things out. I live in Maine. I've got a whole home heat pump system. It works amazingly. We're in climate zone 6, and numbers don't lie for heat pumps in Maine. We installed over 30,000 just last year. We're on track for over 300,000 by 2027. So at Amplys, we're trying to make this transition to heat pumps just a smash success for both homeowners and the companies that are installing them.
Wow. Amazing background and description. Eric Kaiser doesn't look like he's chomping, or Elk doesn't look like he's chomping at the bit, but I'm sure some questions have come to his mind.
The first thing that comes to my mind is I want to know more about what Amplys is doing and how it is going to help with installing heat pumps. And for me, one of the biggest things that I think of when installing a heat pump is we've got to look at comfort. Because if people aren't comfortable in their own homes, they're going to reject whatever new gets put into them. And a lot of the heat pumps today, we're seeing them go into new homes. But one of my things is that we've got just an absolute ton of existing houses out here that if we're going to switch to a lot of heat pumps for heating, we've got to be able to make those houses switch as well and make that switch in those houses successfully and keep those occupants comfortable. That's the first question I've got in my head.
We love that question. Happy to talk about it. So Amplys helps heat pump installers win more jobs and delight their customers with less hassle. We're particularly focused on retrofit homes, not new construction. So your point there is a great one for us. If you're going to do it right, it'll take you hours to size, design, and sell a heat pump system. With our software, it takes minutes. That's fundamentally what we do. We start with measurements. So using a mobile device, you can scan the home to get exact measurements, get an instant and accurate load calculation that can be tailored, pick the right equipment, put it in the right spot. So you design the holistic system and produce a document that can go to the homeowner or the install team with like really accurate notes, measurements, placement for everything such that the install goes right. So to your point about comfort, we are fundamentally trying to make it easier to size and design the system such that it meets the homeowner's needs in a way where there is no trade-off between accuracy and speed anymore. Eric, you can be as accurate as you want and go as fast as you've ever gone with no trade-off.
Very nice. Interesting. So you mentioned scanning a home with a device. What kind of devices are we talking about here that are required to scan a home?
Today, we're using consumer mobile devices, and the only products available today that can do this, that they have LiDAR capability and they have a camera package that is important, are the Apple iPad or iPhones have the right hardware. We're currently focused on iPads. We think it's a better experience having a larger display. So it's leveraging LiDAR on the device and machine vision. So LiDAR allows you to take these accurate measurements. Machine vision allows you to detect, hey, this is a window, or this is a wall, or this is the floor, and differentiate between those different things in the space.
So is that any iPad, or there's certain iPads that have this LiDAR in them? How does that work?
Yeah, great question. So it's any of the iPad Pros. So those have been around since roughly 2020 or 2021. But if it has Pro in the name, it's going to have the LiDAR capability.
Nice. There's a few of those out there.
You don't need to go buy those like giant things for like a Matterport scan. If you've seen those, like apple.com.
I have actually. I've seen those. I've seen them used. And that's why I wanted to ask that question, because sitting there watching a Matterport scan happen is kind of like watching paint dry.
Yeah, well said.
It takes a long time to do that. So I'm excited to see something like this coming into the space, and I'm really interested to learn more about it here. I think there's a couple companies that are looking at this technology out there now, and it's definitely interesting to me to see it evolve and become mature in the marketplace.
So just to put sort of a marker on that, the 11-inch iPad sells for about $800. The 12.9-inch around $1,100, $1,200. So just give people a framework. It's like not a huge lift to get a tool that gets you access to the software. Now, where does that software reside? What do you do to actually get going with this?
It's a great question. So right now it's in the App Store, but you've got to go through us to actually get access to it. And that's because we're changing this software as fast as our fingers will fly over the keyboards to write code. So you can feel free to go to the App Store and download it. If you wanted access, best thing to do is go to www.amply.energy and just hit book a demo or contact us. And that goes straight to me, and we'll get folks set up if they wanted to use it. But we envision that as this matures, you don't have to go through us at some point. You're just interacting with a website or the App Store in order to download it and use it. We want to make it as easy as possible to get this in people's hands.
And it sounds like you've had customers or alpha, beta users working with the product, like really right in the field. Tell us a little bit about that.
Yeah, we've had this in the field, in users' hands since July. And so we've crossed over into just customers now using it, which is great. But we've got this this was data that I was looking at every day, but HVACR symposium got me a little disconnected from the 30, 40, 50 users, something like that, all across the US, and getting great feedback so far. What we're hearing is it is saving a tremendous amount of time. It's delighting customers. It's increasing conversion rates. Like, people feel like they're winning out there because they're using this, because it's such an engaging homeowner experience, and better margins on jobs, like fewer callbacks, like just more accurate designs that go in better with better customer success.
So I'm curious as to what this really looks like from the user's perspective. And you mentioned earlier being able to take measurements, put equipment in, things like that, to be able to show the installers for a better install experience, which ends up being a good customer experience if the install goes smooth. What kind of measurements can you take? Talking about equipment placement, can you do takeoffs for ductwork and things like that? What all can the software do?
Sure. So from a measurement perspective, we're focused on the geometry of the house, things like windows and doors and walls, everything that goes into an accurate manual J calculation. So you can also modify key assumptions that are required by manual J. So for example, you've got a 2-story building. The ceiling of the first floor is in contact with another conditioned space, so there shouldn't be any loads for that ceiling. At the moment, no other calculations for ducts. That's something that's long-term roadmap consideration, but not today. We allow the user to take pictures of the install location of the outdoor equipment and of the indoor equipment. We can visualize what that equipment looks like as well, so that it can be scaled appropriately given where the picture was taken, so that the homeowner and the install team have a sense of what it's going to look like and where it's going to go. And then you can take detailed notes in various places in our product, so that in addition to having that photo or that 3D model, you've got that language right there that keeps everybody on the same page.
You mentioned load calculations in here, and obviously we like to see manual J approved load calculations. Is this software approved for manual J, or are you using somebody else's software as an engine to do that calculation?
Not today. We are not certified. We are doing this completely in-house. We think it's so critical that we wanted to own it from end to end. We are in the middle of the certification process with ACA, and hope to be approved here very soon.
But we agree, Eric, ACA approved is the bar. And so it's absolutely critical, and we're pursuing it.
Nice. Probably later this year, I would guess, maybe on that process then.
ASAP is what I tell people, but it's Wes's call. So when he's ready to give it to us, we'll be thrilled to take it.
Nice. I've never been through an ACA approval process or talked to somebody. So I'm just going to ask that question a little bit about what's that like? What do they look for in software to make sure that it is doing what it's supposed to be doing?
We've been really impressed with their process. It's really rigorous. They start off with something basic, which is just a checklist of what are your defaults for certain parameters. They're prescriptive about certain things we can't use for defaults. So for example, we can't have a default window size. They want to make sure that's being measured every time. The next step is they've got a test house, kind of a make-believe home. They call the Bob Ross home. And we have to do a load calc for it. And they compare what our outputs are to what they think they should be. And we need to be within a certain percent tolerance around those. There are hundreds of parameters that are being calculated. And from there, it's a bunch of detailed sensitivity studies. So we start with that base home, and then we have to vary a whole bunch of parameters to see that the software is responding appropriately to those changes. And they're also very serious about what information is output for the end user to make sure it complies with the ACA Manual J, really J1 form, so that there's a standard set of parameters that everybody would see if they are looking at a certified load calculation. And then they're actually going to use our product. That's the final step, is to put it in their hands and they play with it and make sure there's no other surprises.
Sounds like some pretty rigorous evaluation. So that's good to hear.
Yeah, for sure.
As it should be, yeah. I'm going to jump to another topic, which we previewed and asked you to think about, was you had a booth, an exhibit at the HVACR symposium, your first year there. What are some of your observations, your takeaways from that event?
Yeah. Eric and I sat next to each other on the plane ride home, basically for 2.5 hours straight. Just talked about the 3 days we spent there, how much we learned, what did we take away from it. So we're not going to give you all of them. We're going to give you our 5. I think that your listeners will think they're the most interesting. And also we have a little bit of a perspective.
Yeah.
Takeaway number 1 is just because it was our first time and we were amazed by the openness, gratitude, and focus on doing things the right way. Bill, I know you're a driving force behind #BetterHVAC. Elk, in one of your presentations, you started out by saying, this industry has given me so much. And then you went on to just share wisdom with everyone who was sitting out there. And I have to say, that mentality permeated the entire event. It seems like everyone there is in love with HVAC. Everyone there is willing to be perfectly open with anyone else. They could be competitors in the same market, and they're still willing to share best practices, insights, whatever. It's like everyone was there and locked arms to just lift the industry up. It was a passion and generosity that, having listened to Brian's podcast and this podcast and a bunch of others, I knew, but to be there on the ground and feel it was surprisingly powerful. That's our first takeaway.
Very interesting. Yeah.
Very cool to hear.
Yeah, it's like being in a different place. I don't know how to describe it. Just
Totally. It was amazing that I told folks it was like this grassroots event for HVAC nerds. And it proves its grassroots credentials by literally being held in a parking lot and a warehouse. It doesn't get much more grassroots than that. But anyway, it was just incredibly authentic.
The warehouse thing really does remind me of a lot of trainings that I've been into in the industry over my years in the industry, because they often get held in distributors' warehouses or a back room in the distributor that gets used once a month for training events, and they have to clear all their other stuff out of it. It really does feel like home in that way.
Our second takeaway, which honestly we were surprised and honestly a little bit disappointed about some of what we were hearing or what the view was on cold weather heat pumps. This might get a little spicy here, but this is our wheelhouse, particularly heat pumps. And we were expecting to see more folks on stage, more representation in general from contractors that are in Maine, New York, Massachusetts, places where there's a large percentage of a lot of cold weather heat pumps are being installed. And we didn't see that. We wanted to share a couple of things that I think we see and experience just in the markets that we're operating in. And one is that heat pumps definitely deliver on capacity on design day. And just like any other equipment, as long as they're sized right, they can deliver on that requirement. But they also deliver on comfort. Elk, you brought this up earlier, asking about heat pumps and comfort. One of the most amazing things, particularly about cold weather style heat pumps, is that they're generally variable speed inverter driven compressors. And they have a turn down ratio, often as high as 10-1. So they can ramp from 2,000 BTUs of capacity to 20,000. And unlike a staged piece of equipment, it's not these big steps between that range. It's this continuously variable hundreds of points from that min to max. And so that means that you've got dramatically reduced short cycling. Capacity matches loads for hundreds more hours a year. And that means you get great comfort and you get pretty darn good moisture removal. Because that equipment is operating at steady state, the coil is staying cold, you're getting good moisture removal. So the criticisms we were hearing and some of the presentations, maybe they would have warranted 15 years ago, but not today. Cold weather heat pumps work. They work great.
Yeah, I can say sometimes it is difficult to catch a whole industry up on the very latest technology. And as humans and as an industry, we get jaded from past experiences, especially negative experiences on things, right? It's like, hey, we had this happen to us. Why would I take this chance a second time or a third time or a fifth time or a 12th time? So I can see where there's a lot of skepticism there, and some of it deserving, some of it not.
Totally. And it's especially hard if you haven't experienced it yet for yourself, this particular technology, then it's uncomfortable when you don't know. But we work with companies that have been operating, just all they do is install heat pumps. And they've been doing it since 2006, and specifically cold weather heat pumps.
In Maine, cold weather heat pumps in Maine, and they work. But Elk, your point is you only need to hear one nightmare story for that to really stick with you. And it takes a bunch of success stories to like wipe the nightmare story away. So the lag there makes sense to us. We offer it as next year, it would be great to have someone up there who is from Maine, who has just been installing heat pumps for 15 years and hear them live, like how it works for them.
I'm sure Brian would be more than happy to entertain anybody that wants to apply to speak at the event. He lets me speak every year, so I'm sure that anybody else is going to be welcome to speak. Because really, that's what it is all about. I mean, it's all about sharing knowledge. It's all about giving that knowledge to everyone else around you to lift the whole industry. Multiple people have said it. When everybody goes up, all boats rise. You raise the ocean. And we got people like Chad Simpson out there who runs a really successful contracting company in Ohio. And he opened a training center, and he's literally training other companies. He's literally training his competitors in his backyard, just like you mentioned, to do better and do better things.
That's awesome. And that's the spirit we offer these. From our unique perspective, having been there, we offer these in that same spirit.
So it sounds like you're applying to be a presenter next year?
I think Eric is, not me.
It would be fun.
So give me another observation that you came away with.
One big observation we had, and certainly not least of the ones that we've seen, even though we're doing it towards the end, is we loved the repeated emphasis on the importance of manuals J, S, and D. They are the foundation of good HVAC design, and so we couldn't agree more. And Wes and Ed from ACA were certainly hitting those points, but so were basically everyone else I saw on stage. It was incredible. The procedures are great. They're the culmination of over 50 years of collective industry knowledge. I think there's a general consensus that they're not as widely used as they should be. And the reason is there's a UX problem, a user experience problem, which is a software term for it's more of a pain in the rear than it should be. And so people have been forced to decide between doing the work quickly or doing it accurately. You only get to choose one. To do it accurately requires getting through a significant learning curve. And we think there's a great way to leverage these procedures that's both accurate and fast. We think software can solve that problem. Basically, how do you make the data entry more automated, faster, more accurate, such that the human is jumping to the part where the real decision-making and perspective and nuance is required, fine-tuning it to the situation. So that was a big one. And we saw a variety of representation from interesting software solutions in this area. Quick Model, doing really interesting stuff. And so we're excited about this movement of software around making manuals J, S, and D faster and more accurate so that everyone wins.
Yeah, making those easier, I think, is going to be a big movement forward in the industry. It's always interested to me, right now, JS and D, they're the best thing we have. They're what we have. Now, I'm not going to say that they're going to be the end-all, be-all forever in the future. Who knows? We're always coming out with new things. People are discovering new ways to do things. But it's interesting to me in reading through those manuals that right in the front of them, they literally say, if there's a better method, use it. Which that to me was telling about the manual. They're admitting right up front that, hey, maybe there is a better way out there and maybe we should use it. But here's the best way that we have currently. So use this, and people like Amplys and Quick Model and that, and who knows, maybe we'll see what the future holds, right?
Yeah. This is an exciting frontier where you've got a piece of software that offers you instantaneously or darn near instantaneously triangulation of a couple different approaches to load calculations or whatever it might be, which would be a really exciting place to be.
Over to Eric for some follow-on on a comment you made during the electrification panel that I found very interesting, and this concept that we're in the phase of electrification 3.0. And your background certainly lends towards giving us a pretty robust answer there. So take it away, Eric.
Thanks. The context around this, there was a lot of discussion about, I'll say, fear around electrification and whether or not we can do it, and lots of questions. I love always going back to history. So from my perspective, we're at electrification 3.0 right now. Let's talk for a second about the 1.0 and 2.0. So 1.0, this is really about the grid. This is, think FDR, 1930s. This is the Rural Electrification Act. This is when we got electricity to people for the first time across the country. So that was really say the 30s through the 50s. And the second wave, the most recent wave, Electrification 2.0, was about certainly some grid investments, but it was really about the HVAC industry. In 1950, air conditioners finally hit this tipping point where they were actually accessible to homeowners for the first time. So in 1950, I pulled up some of the old data. There were roughly 74,000 central air systems installed in 1950. By 1953, there were about 1 million that went in. And then from the early 50s until 1980, we added another 45 million. So in that period of time, and then from the 80s to the 2000s, the HVAC industry is what led electrification. And they ran into many of those same problems that we're talking about today. Instead of it being, hey, I don't have enough breaker space or service drop, I need more amperage in the electrical panel. In the 50s, they were dealing with fuse boxes with maybe 50 amps of service. But we figured it out and we grew the grid to accommodate it. And it was really the HVAC industry that led Electrification 2.0. So when we think about where we are now, I think Electrification 3.0 should be led once again by the HVAC industry. And I think we've got an amazing opportunity. And we've heard various comments about, is the grid ready for it? Over that period from the 50s through roughly year 2000, we were growing the grid capacity roughly 2 to 3% every year. And we just need to do that again. We need to build out the grid at the same rate. But we have all kinds of new tools and insights and ways to do that better, smarter, faster than we did the previous 50 years. And the grid is clean enough today to make it make sense from an emissions perspective. So in the entire lower 48, right now, today, there are fewer emissions compared to a gas furnace than a heat pump. Wyoming, it's a 15% reduction. In Florida, it's a 65% reduction. So it varies by state. But in every state, there are lower emissions if you are using a heat pump for, let's do it again. Let's lead the way. Let's roll up our sleeves and let's make it happen.
Do you guys have a blog?
Not yet.
Because this just fascinates me so much about the electrification progress, the grid. The questions come so much, but to have someone speak with confidence and backup. Can I offer you to do a guest blog on the True Tech site, Ed, on that topic?
We'd be thrilled with that.
Ed and Eric collaborate on it, please.
Yeah. Do you mind if we co-post it on ours?
Sure. Go ahead. Yeah.
Would be delighted. What an honor.
We just need clarity and information from sound sources backed by data. Elk and I were talking about it on another topic this morning. We love to have data to mush around on our fingers to deal with and to take a look at. Very cool. Thank you, Eric, for that really robust reply there.
I got a quick question for Eric here on that topic and on that grid topic, because I think about the grid as it's already pretty well ready for heat pumps, because a heat pump is, of course, a backwards air conditioner. And we're already running air conditioning in a lot of these places to cool the house. Maybe it takes a little bit more energy to heat the house, but until we get into resistance heat, the grid is pretty well ready. In my mind, anyhow, the grid is pretty well ready. Would that be a fair statement to say in your assessment?
Yes, I think we're ready. And the caveat that you mentioned around auxiliary heat on resistance heating that's often there for those rare hours of the year where you just need a little more oomph. I'm excited about this problem because there's an opportunity. So for every conventional electric water heater that we replace with a heat pump water heater, we free up capacity on the grid for backup resistance heating for HVAC. So a conventional electric water heater, they typically have about 3,000 watts, so 3 kilowatts of resistance heaters in them. When you go to a heat pump water heater, you're drawing continuous about 500 watts or even less, depending on the model. So you suddenly have 2,500 to 3,000 watts that goes away. And that makes space for a normal first step strip heater for a central air heat pump system is a 5 kilowatt unit, a 5,000 watt unit. So right there's a little bit extra that we're adding, but it's not a big stretch. And there's all kinds of great things that we're doing with innovation around electricity rates, time of use rate, and new models for controlling the grid that allow for flexibility in the system to accommodate heat pumps. There's more work to be done for sure, but we're ready today.
To build on that, a lot of conversation at the symposium was about dual fuel. It felt like some of that conversation was due to concern about whether heat pumps could do the job. But Eric and I, we love dual fuel as a solution, but partially because if you've got working equipment in there, no need to rip it out. And second, redundancy is a good thing. And so you've got two options there. So you don't necessarily need the electrostrip heat if you already have a furnace that has a bunch more life in it. We're not necessarily heat pump maximalists. We're like optimization maximalists. And we think heat pumps become like the base load for nearly all the comfort management you need. But depending on the home, you can make smart decisions in order to really optimize what you've got, or optimize using what you have while augmenting it with something like heat pumps. So that part of the symposium narrative around heat pumps we thought was great. We'd tweak the rationale for why dual fuel is the way to go.
Very interesting. This has been a great conversation. Run up to our usual stopping point just for courtesy to our listeners. We should figure out like what the average commute is for an HVAC technician or contractor and then hit it like right on the nose. Let's wrap up. I'll ask first Eric and then Ed for some closing thoughts.
I want to go back to where we started, which is just to say thank you to both you, Eric Kaiser and Bill Spohn. I think you are leading the way on obviously things like better HVAC. I think the openness and focus on doing things the right way that you talk about in your podcast, that you do at TruTech, that we got to experience at the symposium. It's been just wonderful to be part of this industry and to be welcomed into it. And just keep doing it. And we're so excited to be part of it. So thank you.
Thanks for being here.
Thanks for having us. On my end, Brian Orr, during the electrification panel that you were on, Bill, I think summed it up really nicely. He said he gets to do electrification. It's an opportunity, not a requirement. We founded Amplys to make it easy for HVAC companies to seize that opportunity in a way that's good for them. It's good for homeowners. It's good for the climate. So we want to make sure this once in a generation transition, everyone gets to win.
Cool. Thanks for joining us. Ed, where were you from? I know Eric was from Maine.
I'm from Boston.
Boston. Okay, that's right. Yeah. Stay warm. It's a bright sunny day here. A couple times once I had to drop the shade because I was just overheating because it's so darn sunny. Or even though it's cold out, 30 degrees, it's still sunny. So let's harness more electric energy. Let's design better heat pumps. Let's install better systems. Let's just do better HVAC. How's that for closing?
Sounds great. Love it.
Thanks, guys.
All right. Thank you.
Guys, thank you. We're so honored to have been able to do this. Thank you for the time.
Appreciate it. Thanks for listening to this episode of the Building HVAC Science Podcast. If you have any questions or wish to suggest a topic, reach out to us at marketing@TruTechTools.com. The Building HVAC Science Podcast is a production of TruTech Tools Limited. In full disclosure, I'm a co-owner of TruTech. And the opinions voiced are those of my guests, my co-host, or myself, depending on who is talking, of course. If you're in the market for any of the tools or test instruments provided by TruTech, take a look at TruTechTools.com, TruTechTools.com. You can use the offer code HVACBS for a nice discount. If you like what you heard today and you haven't subscribed to the podcast, please consider doing so by finding the podcast in your favorite podcast app and clicking subscribe, or even try asking Alexa. That's a fun thing to do. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, go right ahead. If not, please consult with and hire a pro. As always, we thank you for taking time to listen to the Building HVAC Science Podcast, especially to today's guests, where we talked about heat pumps, homes, and high tech in the HVAC evolution, driven by software from Amplys Energy. Take care, everyone.